And good evening, everyone. Welcome to my channel. And today I am with Jordan, Reason2Doubt, to respond to a recent video from Fraud Matt and Standing for Truth. Um, so Jordan recently did a debate with Professor McQueen on SFT's channel. And needless to say, Professor McQueen got decimated on pretty much every single point. Um, and so Standing for Truth and Fraud Matt were on epic damage control, trying to save face and trying to rebut Jordan's arguments. And of course, they failed miserably. So Jordan, welcome.
Hey, thanks for having me.
So before we get into it, feel free to just give your overall thoughts on the debate and the video that we're responding to tonight.
So the debate went extraordinarily well, probably the best I've had to date. McQueen brought up some interesting points that I hadn't heard upon further reflection, like boron concentrations in Africa. But most of it was the usual line that you hear, what about radio halos? What about NOAA, etc. And really didn't have an answer for any of the math or lines of evidence that I presented. At one point, he straight up admitted that magic was the answer, which, I mean, at that point, you can just pack up and, you're done.
Yeah, exactly.
Yeah.
And
so the response video was clearly put together hastily by two people who don't understand radioactive decay and didn't really follow or chose not to listen to the presentation. And I think that'll become obvious as we play some of the clips. But
yeah, and creationists have pretty much 2 or 3 arguments on accelerated radioactive decay, and they're all pretty bad.
Yeah, I mean, it's, as you'll see, and as you could see during the debate, because the model is so haphazard, every time they come up a problem, they throw up a solution, but that solution creates all these other problems,
Right. It's kind of like playing whack-a-mole. You have this obvious problem with your model, so we're going to smack that, but you're going to create more. Mm-hmm. So without further ado, feel free to pull up the video and let's get started.
Yeah. So as a quick preamble, I reached out to Raw Matt before doing this and clarified some points so I'd make sure I was understanding what he was saying. So I hope I'm representing him fairly. I've kind of organized the clips in my notes sort of by subject. So I'm gonna jump around the video a little bit. You can check behind me. I feel like I've done a fair edit, but please check the original source to make sure that I'm not lying to you or whatever. So the first thing we'll talk about is friction and how that works. So let me share my screen here and hopefully it'll work. Share audio.
Okay.
Cool. So this is the beginning that they go through some like intro stuff about what they're doing on their channel, and this is where it starts. He just played a clip of me.
Like boil the ocean. That's the first thing he says. And then he's basically saying that accelerated nuclear decay also runs the risk of radiation particles and heating up the ocean so much that it would boil them, and it would throw those particles into the land and they would get into the plants. Jordan is essentially mixing 2 arguments from 2 separate models to make the heat problem a bigger issue than it actually is. So let's break this down by first me telling you, for one, catastrophic.
All right, can you stop right there? I do want to respond to one thing that he said. To really understand the veracity of the heat problem, we really ought to sit down and calculate the various models. Okay, how much heat would have been generated from the catastrophic plate tectonics? How much heat would have generated from accelerated radioactive decay and all the other forces that have been present? I think that'll be a fun little experiment to do. Just sit down, do the math. How bad is the problem?
Yeah, and if you wanted to get a complete and total picture, you'd have to take it model specific. But the debate itself that this is from was on accelerated nuclear decay by itself. So that wasn't model specific. Any model that features accelerated nuclear decay would have these problems.
Right.
So what he started with, the first thing he misquotes me several times. He said that I said that the friction that's being caused by the plates would boil the oceans. I mean, maybe they would, but friction was no part of my my point. But now
the heat from this model comes from friction, from accelerated nuclear decay. So those two things, the rocks grinding across the other rocks, and then happening so quickly that it's causing like a fission, and the nuclear decay is
I'm sorry, did he really say what I think he said?
Yes. So what he says here is that the friction of the plates, and he's attributing this to me, but that's not what I said. The friction of the plates would cause fission, and that the heat would cause accelerated nuclear decay. Now, in the interest of fairness, I tried to clarify this point with him. His clarification in the email didn't really help. I just think it shows a lack of understanding of how radioactive decay works. Friction does not induce fission. We'll just start with that. I don't know if I don't know what he's thinking, but friction and fission and nuclear decay are three separate phenomena that have nothing to do with each other. Well, I guess fission and nuclear decay could have something to do with each other, but
yeah. By the way, is there any way you can turn up the volume? Let's see. I'm going to try to see if there's a way to turn everything up.
I've just maxed the volume.
Dates of the rocks.
Here we go. Much better. Much better.
Cool. All right. So, yeah, first off, friction has nothing to do with my model. Nextly, he says that accelerated nuclear decay would throw radiation particles, I guess he means radioisotopes, onto the land, and then they'd get into the plants, which is just not how anything works. It's not like the accelerated nuclear decay is going to cause like confetti bombs of radiation, like if your model includes the radioisotopes already existing, like the catastrophic plate tectonics does, then those radioisotopes are already going to be present in the atmosphere. They're going to be present in the ground. Therefore, they're going to be present in plant life and animal life. They don't just I guess unless God uses his magic space wizard powers, they don't just show up at the moment of the flood. So, yeah, that's
and rocks continue to grind against each other all the time. We have major catastrophic earthquakes. Why isn't there accelerated radioactive decay going on in them? And why is it that when we do when you take the geologic column, why is it so uniform across the world? And you can take the Jurassic layer from anywhere in the world and you get the similar results. And
right. If it was simply local conditions like these grinding plates that were causing the accelerated decay, then why do we see uniform geologic features everywhere? Why are there they say that the halos, for instance, and we'll get into this later, but the halos take 500 million years of radiation to form. Why are they everywhere? Wouldn't they just be at the plate boundaries? The whole model just doesn't make any sense.
Yeah,
but regardless, that's not what I said anyway. So then he gets into, he was very offended by my use of this banana picture. So we'll start here.
Issue. Then just say you don't believe in the model. Now, Jordan's argument on Noah and potassium is what we're going to get into now, right? Because that's what it is. Potassium-40 is a radioactive element. So basically, you can see that
he got something right.
Grabbed an argument without studying either bananas or the different forms of potassium that exist, nor the different flood models that he's used in the debate. And I'll explain why. Because
then he something. I'll jump a couple seconds ahead.
Basically magically grew modern day hybrid banana fruits. Okay, think about that real quick. Bananas that exist today look like this. You see that? That's a modern day banana on the right. So these are what Noah grew these bananas, because that's what Jordan says. Look at the picture.
Stop. Jordan, all right, stop right there. I'm kind of dumbfounded here, because this is pretty much evolution via artificial selection. Um, you can say that the bananas we have today are intelligently designed by humans, just because God obviously didn't understand how to create bananas. But that's just a side rant.
Yeah. More importantly, I never said anything about bananas. I put there is a picture of a banana on the slide. It's there because in the nuclear industry and elsewhere, the radiation from bananas is a running joke. You know, we would sometimes express things in school in terms of banana equivalent radiation, just because units are fun, I guess.
Yeah.
So that I did not, just to be completely clear, did not say one word about Noah eating bananas because my argument did not rest on bananas.
Yeah, exactly. And he's pretending like bananas are the only source for potassium-40. It looks like.
Right.
So.
I think that's where his head is at. Is like you said, potassium showed a picture of banana, therefore you think Noah ate bananas. But then, so he goes on a long rant about why Noah wouldn't have bananas or whatever. But then he starts saying, okay, well, what if he did have bananas? Then this is where he really starts messing up.
Okay. What you're looking at now is the actual potassium ratio for the abundance of the mineral. So look at number 39. Okay, well, potassium 39 is what? It's stable. It says right there. But yet that's 93.2581% of all the potassium that's on the land today. So we drop down here. What's the other 6%? That's potassium 41. Guess what? That's also stable. It's also not radioactive. That's another 6.7320%. So what are we looking at? We're looking at essentially 93.281% of all potassium that's in nature, just in the form of potassium 39, essentially is not radioactive. That means that 99.988% of all potassium is not radioactive that would have been in the fruit or that's on the fruit. So Noah would have had something that would have had no radiation problems whatsoever.
All right, stop. All right, stop.
Yeah.
That's not how this works. That's not how any of this works. Keep in mind, because potassium-40 has been decaying, that means that there was more potassium-40 6,000 years ago during the time of the flood. And that means it would have been more radioactive. Am I understanding that right?
It would have been. Under the accelerated decay, there would have been more potassium-40. But that's really... So the problem is much worse than that. You don't need to go that deep. You can just take him at his word right here. These abundances are about... I didn't actually check the natural abundances, but it seems about right. And the half-life is correct. But what he did was he said, well, the prevalence is a small number, the abundance is a small number, and small numbers are okay, so it must be fine. That's not good enough. You have to do the math. You can't just say it'll be fine. You don't know it'll be fine. So under accelerated decay, would 0.01% actually be a problem? He clearly didn't do the math on it, but don't worry, I did. So I'm going to share the math now, and we'll walk through it together, and we'll find out if, in fact, 0.01% is okie dokie, right?
Okay.
So, yeah. So let's just take the banana. I didn't say bananas. I don't know why he's all about bananas, but let's just go with bananas since he's all angry about him.
Yeah,
right?
It looks like I guess you could say that Frog Matt is bananas about bananas.
Yeah, since he's bananas about bananas, we'll just stick with them. Okay, so let's do the math. Bananas have a little bit over 400 milligrams of potassium, and 0.01 whatever percent of that is potassium-40. So that's 49 micrograms of potassium-40. So we need to ask the question, how dangerous is that? Well, this is the formula for radioactive activity. That's the activity. This is the number of atoms in your sample, and that's its decay constant. This is that term in half-life, which people are more familiar with. In order to know the number of atoms, you do this formula. I'm not going to walk it through. You can pause it if you want to read every variable. If you just put those two together, you get this formula. And so if you crunch the numbers with today's decay rates, the activity of a banana is about 13.1 becquerels. A becquerel means 1 decay per second. So in your banana on your counter, about 13 potassium-40 atoms are decaying every second, which is not dangerous at all. But we're not talking about today's decay rates. We're talking about accelerated decay rates, right? So this is what it is in today's rates. I'm sorry, I had one more slide, but this is the amount of energy that is decayed. Every decay releases 1.3 mega electron volts, which is just a unit of energy, just like joules. So that's it in joules. Your bananas put out 2.7 picowatts of energy. Not a whole lot. But anyway, we're accelerating the decay, so we can do the same calculations, but just compress the timeline, or you could multiply the heat by the 2 billion years if you preferred. So under accelerated decay, a banana from just its potassium-40, from just that 0.01 whatever percent, is putting out 173 kilowatts of energy. That means that many kilojoules every second. So how much is a kilojoule? Let's put it just like I did in the debate. Let's use specific heat and put it in terms of temperature, because everyone knows temperature. So the specific heat of bananas is 1.7 joules per gram Celsius. That means every joule will increase the temperature of your banana, 1 gram of banana, by 1 degree Celsius. Usual banana is about 118 grams. Plug it into that formula. So in the first half second, which is 1 half-life under this extremely condensed schema, your banana would increase by 418 degrees Celsius. Presumably, it would explode at that point. They'd get it onto the thing. God would turn on accelerated decay, and every banana in the place explodes. So I guess we don't have to worry about Noah eating the bananas, since there won't be any bananas. But it's okay. If you thought that was fun, it gets worse. Because he wasn't content to just do the abundances. He had something else to say. So I have to change the screen because we're doing audio.
And this is why Standing for Fraud and Fraud Matt really need to sit down and do the calculations, show the math, and show your work. If you can't do that, go home and shut up.
So then at 20:55, so a little bit later.
We know that if you take these bananas and you
sorry, I was cut off.
By the way, you gotta love. I just noticed that Fraud Matt is actually wearing a banana shirt.
Yeah, I assume you wore it for the occasion. It's actually a cool shirt.
We eat radioactive foods today, don't we? We know that if you take these bananas and you walk through an airport, it's going to set off the radioactive counter. We know they're radioactive. They don't cause us problems. Why? Because potassium is water soluble, right? So if it's water soluble, that means that when you eat a lot of it, your body gets rid of it, because potassium only stays in the body about 120 grams of it at a time. It's called homeostasis, right? It's like the balancing act of potassium. You need it, and your body's like, okay, I'm at homeostatic control. That's what it's called. So what happens when it goes above that? Your body lowers it, gets rid of it. It's too low, it'll absorb more potassium.
So, first of all, he's wrong. That's not why it's not a problem. It's not a problem because we're not under accelerated decay, so the amount of radiation that your banana puts out is not enough to harm you. But he's about right that a human body will hold about 120 grams of potassium. It depends on your weight, so it varies, but that's about close. So I actually hadn't considered this before Ramat brought this to my attention. But because of that, that actually gives us a whole brand new exciting way for Noah to die and for the creation model to be, nonsense. So let's do some more math.
Yep. And by the way, when you get a chance, we have a question from the audience. What about radioactive presence in the human body? I think that's what we're about to get to, right?
Well-timed question, because that's what we're about to talk about. So as Ramat pointed out, humans have potassium in your body right now. We all do. It's somewhere around 120, 150 grams, right? Well, some portion of that potassium is potassium-40, about 0.01% of it. And that would have been true for Noah, so unless you're in a flood model where radioisotopes didn't exist, in which case you'd have all kinds of other problems, but that wasn't what we were talking about in the debate, right? So, the subject of the debate was accelerated nuclear decay. So, as soon as Noah gets on the boat, he has 120 grams of potassium in his body. Then accelerated decay heat hits, and then things get fun. So you can run the exact same calculations we just did, just use 120 grams for the potassium, 62 grams for the mass of the person, that's an average human weight, and then I found out the specific heat of a human being is 3.6 joules per gram Kelvin, so gross, but anyway. So from just the potassium in his body, at the moment accelerated decay happened, in one half-life, which is half a second, the temperature of Noah's body would go up by over 100 degrees Celsius. His blood would literally boil. Immediately. Like, as soon as the flood happens, Noah, the chickens, the cows, everything, boom, blood boils. They all fall over dead.
Yep.
Yeah, so I thanks to Raw Matt for pointing that out to me. I hadn't considered it. Yes, you have radioactive isotopes in your body. Those two would be accelerated, assuming that it was done by some kind of actual constant. They never give us a model, so it's hard to say exactly. But any kind of plausible way that you could affect radioactive decay, that's what would happen. But we don't have to stick with bananas because, again, I didn't say anything about freaking bananas. We can go, if he's so pissed about banana talk, we don't have to stick with that. We can go with something that Noah would very likely have. Bread. We can just talk about that. So bread is also radioactive because everything is radioactive. Wheat is radioactive because we live in a radioactive planet. So you can look at those sources for your annual dose from wheat. You're welcome. Is about 0.213 millisieverts per year. But under accelerated decay, that you get 2 billion years of decay. That means 2 billion years of dose in 1 year. So under accelerated decay from the bread that Noah's eating, presumably, he would get, what is that, 6 times a lethal dose every hour just from his bread. See, this is what happens when you just break physical laws. Bad things happen. Harmless things like wheat can suddenly become deadly when you just, make the natural laws do whatever you want.
Yeah, by the way, just asking for a clarification from the audience, only 0.01% of the 120 grams are potassium-40.
Right. So if you run the calculations using 120 grams for the total potassium, and then 0.01% of that is potassium-40, and move on down. Yeah. So if you I made an Excel spreadsheet to do the calculations. And so I had a number for like total potassium and then a percentage. And then so I just changed the total potassium from 422 milligrams to 120 grams. Percentages worked out. I changed the mass of my banana to 62 kilograms, and there you go. So yes.
All right.
Yeah. So yeah, the bread will also kill you. And I think this highlights a major misunderstanding of what's going on. It's the factor from the NRC or for similar other sources isn't a radiation dose for banana eaters or bread eaters or anything. It was for everybody. Like everybody gets a dose from your food.
Yep.
So now that we've dealt with bananas for some reason, I wanted to, and I don't want to spend a lot of time on this, but he harps on this a lot. The fact that I didn't talk about the model he wanted me to talk about. So I'll just one quick example of it when you're ready.
Yep. Go right ahead. Real quick, I wanted to point this out real quick. It is appalling how some creationists blatantly ignore sound science in favor of incoherent rescue devices. They're guilty of the same willful ignorance that the Bible accuses non-believers of. Boom.
Yeah,
right there is that. 100% that.
Nail on the head. And I used to be a young Earth creationist, and whenever someone would come up with a problem that I hadn't heard of, I'd run straight to AIG and find whatever ridiculous surface level answer they'd have, consider it solved, and then walk away. Because they've already decided what the truth is. The truth is that what the Bible says is literally true. So you have to force everything to fit in there, no matter how shaky it gets.
And that is the very definition of dishonesty, because you're starting with a conclusion and trying to make every single thing fit that conclusion, rather than taking the evidence and letting that lead you wherever it may go.
Well, I wouldn't necessarily say it's dishonest. When I was a young Earth creationist, I genuinely believed I was doing an investigation. I was just so deep in an echo chamber and full of cognitive dissonance that I literally couldn't see it.
Yeah, and I was the same way when I was a young Earth creationist.
Right. So it's all you have to do is just put aside your model, put aside all that. Just look at the evidence. If your model's correct, if the Earth is really only 6,000 years old, the evidence will show you. You don't need to force it to do that. So if you just honestly examine the evidence, you have nothing to fear from it.
Right, exactly. And God is supposedly not a liar. So that means when we examine the nature, if Christianity is true, we're examining nature and we're examining the nature of God, then it should lead us to the conclusion of the Bible.
Right. I forget who said this. I want to say Jefferson, but I'm probably wrong. Someone in the comments could correct me. But the quote, I refuse to believe that the same God who endowed me with intelligence intended me to forego its use. If like you said, if God really did create the Earth, he would know that we'd have to be inquisitive and ask questions. I mean, he'd have to be deceptive if he would hide all the evidence of what he did, But anyway, so he is now complaining about me not having the debate he wanted, I guess.
Yep. No audio. I can't hear the video.
Oh, I must not have shared my audio.
Yeah.
Bad. There's a little button at the bottom that I've neglected to press. I'm sorry. You missed 10 seconds of Raw Matt talking. What are you going to do? All right.
Best case scenario for Jordan's argument, it falls apart because he didn't investigate either of the models. Like I'm saying, he didn't look at let's investigate that. What would happen if Noah was harvesting food? When was he harvesting it? Well, it was before the flood, obviously. He's not harvesting bananas during the flood. So therefore, all of the things that grew before the flood either didn't have the amounts of radiation, being Walt Brown's model, which would have had none, or let's say catastrophic plate tectonics. Well, guess what? Rapid nuclear decay is only occurring during the flood. That means that all food grown before that time wouldn't have it. I don't think Jordan thought about that very much.
I did think about it. So the problem is I wasn't addressing hydroplate theory, and I don't want to keep harping on this. The debate was on accelerated nuclear decay. So a model that doesn't have accelerated nuclear decay is literally not relevant. That wasn't the debate. We could have that other debate another time if he wants. McQueen subscribes to catastrophic plate tectonics. So if I was going to look at any model, it would have been that one. But regardless, I wasn't looking at any particular model. Any model that includes accelerated nuclear decay would have the heat problems and the radiation problems that I brought up. That's all. And also, if a model doesn't have radioisotopes created by fiat during the flood, as catastrophic plate tectonics does not, as McQueen doesn't believe they were, McQueen believes that they were there the whole time, then that means they'd already be in the plants and the people and everything else. They wouldn't just show up when accelerated nuclear decay happens. He seems to have this weird image that radioactive isotopes are lurking in the water in the deeps and you're going to spring out at you. That's not how it works. But anyway, did you have anything to say about that before we hit the next thing? Because there's plenty.
Nope.
So speaking of water,
radioactive during this time. And that would have been all of Noah's drinking water.
Okay,
it also says that the ocean water would have been highly radioactive during this time. And that would have been all of Noah's drinking water.
First of all, I did not say that. I never once said that Noah was drinking ocean water.
I say, what are you talking about? It was raining during this time.
I agree. What are you talking about?
Oh, I heard myself. Am I right?
Oh, yeah. Yeah.
Okay.
Are you hearing an echo?
And guess what? He wouldn't have been drinking salinated ocean water to begin with without some kind of a filtration. So he would have been reliant on the rain. It rained for 150 days. So we're talking about he had massive amounts of rain to distribute and to save.
So pause it right there. I'm taking that fraud Matt seems to think that Noah must have had some buckets to catch the rainwater and was drinking straight from the rainwater before it hit the ocean.
Presumably. So he goes on, I won't play the whole thing, but after that he goes on and he talks about how raindrops collect around particulates, and that the only way that that the rain could be radioactive is if the radioactive particles were in the atmosphere, but they were all in the ocean, so it'd be fine.
Yeah.
And that was another thing I asked him about in my private correspondence, and I'm pretty sure that's an accurate portrayal of what he said. So it is true that water can be radioactive because it has radioactive particulates suspended in it. So that is a way it can be radioactive, but it is not the only way. First of all, the water itself can be radioactive. So there is a radioactive form of hydrogen where you have a hydrogen atom, which is just a proton, and then 2 neutrons. That is called tritium. So 1 hydrogen and 1 neutron is called deuterium. When you have deuterium in your water, it's called heavy water. They mention that sometimes on this channel. They use it in nuclear reactors. You got 1 more neutron in there. It's tritium. Tritium is radioactive. So that tritium is the water. It's the hydrogen in the water. So that's going to be in the ocean. When it evaporates, it's going to be in the clouds. When it rains, it's going to be in the rain. It's part of the water. And then Noah's going to drink it, and he'd take a dose from radiation. Now, so if you take a Geiger counter, we did this in school, you can take it to your tap water, and you'll detect some decay from your tap water. It's not enough to hurt you, but it is there.
Yeah.
Not only that, but there would be, under most models where radioactivity didn't just suddenly appear, there would be radioactive isotopes in the atmosphere. For instance, carbon-14 is created in the atmosphere. That's where it's from. So as the rain goes through, it would catch that. That's why rainwater today is radioactive. It would also wash out radon from the air. The tritium itself is created in the atmosphere. So yeah, the rain would be radioactive. The food would be far more dangerous than the rainwater, but it would be radioactive.
Yep. And pretty good comments here. Rapid decay of radioactive isotopes of elements vital to biology is why I don't really like accelerated decay. I'm a creationist. If accelerated decay happened, it would have had to be very selective. Exactly. It would have had to have somehow affected the rocks, but not Noah and his food and all of that. So yeah,
right.
This pretty much hits the nail on the head.
If you want, you could make a model where God puts a magic no radiation bubble around the ark, and like he makes the radioisotopes at Oklo behave one way, but the radioisotopes everywhere else behave like. If you're willing to do that, you can have an answer, I guess. But if you want to be consistent, there's no consistent answer that involves accelerated nuclear decay.
Yep, exactly.
So that's he goes on for a while more, but he doesn't say anything else important. That is his rebuttal of the accelerated nuclear decay part. So there you have it. Then SFT goes into the heat problem. Do you have anything to say about radiation before we go on to heat?
Nope. I'm definitely excited to see what he says about this.
Oh, it's awesome. It's going to blow your mind.
Oh boy, I can't wait.
It won't, probably. So let's see. 37.
Hold on 1 second. Jordan, I've seen Matt and SFT claim the presence of C14 in diamonds and dino bones as an argument for recent creationists. Has this previously been debunked? I'm pretty sure it has, but it might be worth doing a video about. But that would be a pretty good separate video. In short, I do know about the claims from carbon-14. The problem is carbon-14 is only useful up until about 50,000 years. After that, it's just so little left to be useful. And all of the diamonds that Dr. Snelling touts are well older than 50,000 years from my recollection. I'm not sure about the carbon-14 and dinosaur bones. Maybe Jordan knows some more about that.
So Snelling and the rest are not claiming that the diamonds are less than 50,000 years old by virtue of the carbon-14 in the same sense that you would carbon date an apple or whatever. So it's not that per se. What they are saying is that they detect carbon-14 in diamonds and other things that are supposed to be old. And because carbon-14 has such a short half-life, if the Earth and these objects were in fact billions of years old, you'd have no carbon-14 at all. You'd do your test and come up with 0, right? And therefore, because it doesn't come up with 0, boom, checkmate atheists, the Earth is only 6,000 years old or whatever.
Yeah.
we could definitely do an entire video on that. But the short answer is that if you look at the work they do and the results they get, they are all extremely small, corresponding, if they were biological material, to a date somewhere around 50,000 years. It's a very, very, very tiny amount of carbon-14. The reason that we don't use carbon-14 dating past that certain age is because when you get to that small, tiny amount of carbon-14, you start losing it in the background signal. Every test is going to have sources of error, even though the scientists do a phenomenal job to reduce those as much as possible. There's no way you could ever reduce them to zero. I have a good paper if you want to look about this. Okay. So did I actually put the citation? I can put it in the comments. I found an awesome paper in case the carbon-14 came up during the debate, but it doesn't look like I put a link to it because I'm an idiot. But I'll put a source. It's been dealt with in the literature, is what I'm saying.
Yep.
Damn, I'm really frustrated I didn't put a title because it is an amazing paper. Whatever. I'll put it in the comments.
Okay, yeah, put it in the comments. Feel free to put it in the sideboard chat as well.
Yeah, if I find it, I'll put it up there. But one really quick quote from it, just to give you a taste of it. They say, every sensitive modern analytical instrument of which we are aware, no matter what type of physical entity such an instrument has been designed to measure, exhibits some type of background or sample/machine blank signal. There is, as far as we know, no exception to this statement. If you read peer-reviewed literature, then it'll hit you that is a statement. Like, I have never seen a statement that strong in peer-reviewed literature, ever. Like, that is, you will not find a more absolute statement than that.
Yep.
You know, it just a blank, no exceptions, no like hedging. This is fact. Like, that just, that just shows how ridiculous their assertion is. They always want to say, well, the lab technicians are really professional. Well, sure, they're professional, but professional doesn't mean you get to zero.
Yeah, exactly.
And the natural question after that, and I don't want to derail too long, but the natural thing after that is, well, if it has error, why is it reliable at all? Well, if you have this much error and your signal is this big, it's not a big deal. But if you have this much error and your signal is this big or nothing, it is a big deal.
Right, exactly. And there's a margin of error for everything we do in science. If you take a sample and put it on a weight, there's going to be a margin of error there. That's just a fact of life. That's just a matter of science. There is always a margin of error. And what they're doing is akin to using a bathroom scale to weigh a semi. You're not going to be able to do it for obvious reasons.
Or a semi-scale to measure a pinch of salt. Like, it's just not going to happen. Yeah. And if you look at the RATE project, they have a table of like, oh, here's the diamond we found. One of them, my favorite one, came up with a percent modern carbon is the measurement when you don't convert it to years. Percent modern carbon of 0.03 plus or minus 0.03. Dude, that's zero. That's what a zero result looks like. When your plus or minus includes zero, you just throw it away. Like, it's useless now.
Yeah.
Anyway, so there's your answer, and I'll find that paper and I'll put it in the comments of the chat. But anyway, so Raw Matt in the video does the first part. He talks about radiation. Then our boy SFT steps up to the plate, and he's going to take care of the heat problem.
Okay. So,
can you hear the audio? Or did I screw it up again?
I can hear the audio, I think.
Good. Okay.
The heat
Perfect.
needed to produce coal and oil quickly was generated by the global flood itself. Okay. And the heat would be connected to a physical and chemical process. Joseph Hubbard pointed that out, how important this physical and chemical process is that actually leads to the rapid production of huge amounts of coal and oil, okay? So I want the audience to consider this. There is a very strong connection between the rapid formation of coal, oil, and then heat and pressure. Heat and pressure, okay, being components and features of the global flood. So
there's a physical mechanism. What is that mechanism?
Who knows?
Well, yeah.
By the way, excellent comment from Carrie. Hey, if they can get the number of Earth vaporizations down to a single digit, I'll credit them with Perfect. Excellent.
Yes. If I think like step one is to make sure that the Earth is vaporized like a minimum number of times.
Perfect.
Awesome. Love it. I'm just going to play a couple. I'm going to play a couple clips that show. I want to show like all the work he does in this thing. I want to get it all out so we can deal with it all at once. That the good work he does dealing with the heat problem
was there. Okay, that's why the pre-flood world, when you look at the bigger picture, the pre-flood world was the perfect battery to absorb the majority of that heat. Most of the heat, Matt, for there to now not be a heat problem. Because they're
all right, stop right there. Is he really suggesting that the Earth being perfect would have dealt with the heat problem itself?
So what he's saying is that the conditions on the pre-flood Earth situated such that it was a perfect battery, a perfect heat sink, is what he's saying.
Yeah, thermodynamics is actually a thing. Is he aware of that?
I'm not sure. Maybe he took his course from our boy Neff free. He's an expert on the second law in particular, and how it means disorder and not entropy.
Yeah, he must have, and I'm joking here. He must have got his degree from Trump University.
All right, 2 more clips, I promise, and then we'll get through with all his good work.
And any other heat that's just dumped into space. Now, anybody can look to the hypercane model. Anybody can look.
I was amazed that he had the balls to bring up the hypercane model, by the way.
Yeah, he brought up the hypercane model, but did he even try to show your math to refute your math?
Don't worry, I'm gonna thoroughly refute his math.
Oh boy.
The amount of water that would have been on the Earth, miles and miles of water that would have been on the Earth at the time of the global flood, that could have shielded Noah, shielded the ark animals from the excess radiation and the heat.
All right, stop right there. I pointed this out in the past. The actual temperature in like a nuclear fission or whatever in a nuclear reactor is over the boiling point of water. So I don't know why he keeps bringing that up, because that'll just vaporize the whole Earth and boil the marine animals alive.
Well, I mean, the amount of water it is a heat sink, right? So it could absorb some heat. There's a level over which you can't go up so high because you'll start having adverse effects on the life that needs to survive, right? So, I mean, even fluctuating at a couple degrees, it's going to have adverse effects. But, you might be able to get some credit there. But yeah, you can't just like dump it all in the oceans because, again, the oceans, your number of Earth vaporizations is greater than 1.
Okay, and the fact that these supersonic steam jets would have taken most of the heat up into space, all these number of solutions, okay? They can make assumptions, okay, and come up with some numbers that say that these aren't going to work. For one, I haven't seen any numbers based on correct assumptions pertaining to the pre-flood world.
He doesn't tell us what those correct assumptions are. But
yeah, what are these correct assumptions? Tell us, please.
I don't know.
What we do, and Snelling pointed that out too. So sure, there was a lot of heat produced. Okay, a lot of radiation produced as a result. Okay, now we can take these lines of evidence that we find directly in the rocks that suggest periods or a period of accelerated nuclear decay. Okay, and we can come up with a variety of plausible solutions given the assumptions of the pre-flood world and a Genesis starting point as to how a lot of that heat could have been removed and absorbed. And we've got, 10 to 20 roughly,
So he has 10 to 20 methods. By my math, assuming they're all equivalent to the hypercane, which was his favorite one, he is only just a small 4,480 methods short.
Yeah, and I think you did the math on that. And like for wall-to-wall hypercane, to properly reduce the heat temperature, I think it would be needing to do like 180 meters of water per day.
It was something like that, 180 meters of rainfall every single day in order to be sufficient. But I did take the time, because I want to make sure that I address all these problems. I did take the time to thoroughly go through the math that SFT presented, so I'm going to do it right now. Ready?
Oh boy.
Okay, I'm done. That was it, because he didn't have any. I have refuted all of his math. All of his zero math is refuted.
Yeah, and this is the name of his game. He never brings up math. He never shows his calculation. He never shows his work. Speaking of work, I have just the perfect video of that. This is a brand new video from Guts Gibbon that was just premiered today, about, and hopefully I can find it. Oh yeah, here it is. This is exactly what I wanted to play. And that pretty much demonstrates all of this. If I can get this out to actually play. Screen share audio. Let's see here. Please play.
Got to get that good internet, man.
Let's see here.
Well,
yeah. This is great. Skip forward to about 17 minutes right here. Here we go.
These stone tools are simply
Oh, no.
rocks formed by natural causes. Why doesn't he just drum up a model for that?
I don't really want to do the work today. I don't really want to do the work today. I don't really want to do the work today. I don't want to do the work today. What? What's this? Oh, I don't really want to do the work today. I don't really want to do the work today. I don't really want to do the work today. I don't want to do the work today.
The only reason that
Yep. That's
Nice.
pretty much standing for truth and for all that.
yeah.
And God sake, Evan, if you're watching, thank you for that clip. Oh, absolutely amazing.
Yeah. So all we see from them is just assertion after assertion after assertion. There's no math, there's no evidence. And as we clearly showed earlier with the potassium, you can't just say, oh, it's small, so it's good enough. No, you have to do the work. You have to do the math. And I have done the math to show that, and it was very simple. It wasn't like peer-reviewed level. You don't have to be have a doctorate to do it. I've done the math to show that the Earth would have a serious heat problem, such that the temperature would be above 90,000 Kelvin, enough to vaporize the Earth several times over. So if you want to say that the heat problem is not a problem, well, prove it. Like, show it. And the fact that I did the math on the hypercanes, and it did what, 0.02% of the heat?
Yeah.
But you're not even going to notice that. So
Yes,
that
exactly.
he can flatly assert that the heat problem has been taken care of as many times as he wants. It's not true. It won't, and it will never be true until he does the work.
Yep. And apparently he just doesn't want to do the math.
Want to do the work today?
Yep. I don't want to do the work today.
Yeah. So that's I mean, there's not much to refute because he just didn't show anything. So far as I'm concerned, the heat problem is still outstanding, and I expect it forever will be.
Yep.
Now, so I do want to say though, there's a reason. Like, he considers the young Earth a fact, right? And for so far as the accelerated decay comes, he points to things like radio halos and fission tracks as evidence, physical evidence, damage in the rocks that this happened, right? And he says his logic is, well, these phenomena mean that there was accelerated decay. So therefore, there was accelerated decay. And if there are any problems, there has to be an answer for them, even if I don't know it. Basically, it's the way his logic works.
Yep.
But if your model tells you that the Earth is going to be vaporized, perhaps your model's wrong. Perhaps maybe that's the problem.
Yeah, exactly. Maybe your so-called evidence for accelerated radio decay, such as the halos and the helium, perhaps maybe there's a better explanation for that than vaporizing the entire Earth 50 times over.
But it's honestly even worse than that, because he goes to the rate project and people like Andrew Snelling, and I have to give Snelling a little bit of props, a tiny credit where it's due. He brought up the heat problem and he said it is a real problem. It would melt the earth, and I don't know how to fix it. I mean, so at least I'll give him credit for that, even if he didn't then like follow that to its logical conclusion. At least he went that far.
Yeah, I will give him credit for that.
Yeah. But that said, so Standing for Truth and others, they point to the Rate Project and their work on radio halos and fission tracks. For those who may not be aware, we talk about it a little bit in the debate, so you can go watch that. But basically, in rocks, there are dark patches that form around zircon crystals, which have radioactive materials in them. The dark patches are caused by alpha particles, which is charged helium, breaking up the crystal structure. It damages it, so it makes it dark. And then fission tracks, U-238, uranium-238 fissions occasionally, just spontaneously fissions, and it emits a very high energy fission fragment that shoots through the rock and leaves like a track that you can see with your eyes when it fissions. And both of those features are very thermally sensitive. So if the rock heats up, they go away. Annealing is the term. So they are annealed away, and they wouldn't be there anymore. So that's what Standing Truth is. But if you listen to what the rate people say, they don't say these features mean there's accelerated decay. They actually go the other way. And I've got a quote here. This is from the Rate Project. There remains sufficient strong evidence to conclude that both fission tracks and radioisotope ratios in the zircons record more than 500 million years worth of decay at today's rates.
Yeah.
Given the evidence, of a year-long global flood about 4,500 years ago, the 500 million or more years worth of decay at today's rates had to have occurred during the flood. So in other words, it's not that these fission tracks, and they have a similar quote for halos, it's not that these are evidence of decay. It's that given the assumption that the flood actually happened 4,500 years ago, it must be decay. Right.
And this is a great comment. I love it. Maybe they use Mormon magic underwear or Noah family, and really large sign for planet Earth.
I mean, maybe the vapor canopy is really just like magic underwear. Like that's like the brand of underwear that the Earth wears.
Yeah. So we also have a question. Where will the source for the carbon-14 be? Concerning the significance of AMS background 14C measurements by R.E. Taylor et al.
That sounds right. That sounds right. I think that's right. That paper sounds familiar.
Yeah.
I can.
Yeah, and I think he's asking where would the source for carbon-14 be?
So are you asking?
Yeah,
so they detect it. Where would that have come from? Is that the question? Okay. So one possible way. So the first and the most obvious answer is it's not really there. There's a lot of sources for error, and that paper goes into it. Here's one source of error. What you do in accelerated mass spectroscopy, which is we don't use counting methods, or at least if we can avoid it, we don't, because I'm not going to get into that for reasons that you can look up. The way that mass spectroscopy works is they shoot ionizing radiation, and so they ionize the thing you're examining and put it through a magnetic field, right? And because you have different isotopes of different masses, they'll be deflected by different amounts in the magnetic field, so you can count how many atoms you have of different atomic weights. So you could count the ones with weight 12, with weight 13, with weight 14, with weight whatever. Okay, that's how that would work. So you'll notice I said different atomic weights. What Standing for Truth and his crew often say is that they're counting the individual atoms. They can count the carbon-14 atoms. That is not strictly true. You are counting the number of atoms with a certain atomic weight. Carbon-14 is not the only thing with weight 14. Nitrogen-14, which is way more prevalent than carbon-14, also has a weight of 14. And the machinery is incapable of distinguishing between nitrogen-14 and carbon-14. They will show up the same because they have the same mass. Now, the method is saved by the fact that nitrogen-14 doesn't stay ionized very long. It has a very short travel distance as ionized radiation, and so most of what you'll get at the end will be carbon-14, but not all of it. Some of it will be nitrogen.
Right.
And if you have a sample with no carbon-14, all of it will be nitrogen.
Right. And it's also important to note that carbon-14 decays into nitrogen-14.
Yes, that's another excellent point. Yeah. So not just from the carbon-14 decay, not just from contamination from the atmosphere, but also carbon-14 decay. There are other effects. The paper goes through a ton of different sources of error, and it goes through how labs try to reduce those sources of error, but it is explicit and emphatic. You never get those sources of error to zero. You get them to a very small non-zero number.
Yeah, exactly. And another great comment. I said to of every animal with a sigh, Noah welcomed a termite aboard them, then stripped himself bare, ready to receive his final passenger, the parasites.
See, now, you silly atheists, this is where you're not understanding the hyper-evolution that is a critical part of the non-evolution model. Because we bring two of each kind, and then they get off, and they diversify at like just astronomical rates. No diversification beforehand.
Yep.
No diversification before. Only after.
Yep. And rapid speciation that puts the Cambrian explosion into shame.
Right. Yeah. Like no speciation events so fast that any evolutionist would. Now I'm using the term. Any evolutionary biologist would blush. Like.
Yeah.
So. Anyway.
Yeah. When clickbait sites can point out problems with your model, you should rethink your life decisions. I mean, not wrong.
Yeah.
All right. How much more do we have to go through?
So that's all the important stuff. I just have one pet peeve that I want to put out there real quick. It'll take just a minute, but this has been bugging the absolute heck out of me. So I'm going to share my screen one more time. All right, and it's at 107. And so this is him talking about one of the models like has fusion happening below the Earth's surface, and that's where all the heavy metals come from. And in the context of that, he says something that really bugs me.
Why 90% of the elements, these radioactive elements, are on the continents today.
Well, with Walt Brown's model, you've got the creation of these heavier elements, okay, during the flood itself, okay? What results, Matt, correct me if I'm wrong, and maybe you can explain it a little better than me. What results is something called cold repacking, where there's a canceling out effect where that heat is absorbed through the process. Is it right? And we've seen this in real-time experiment. So, there's a model. Did I represent that accurately, brother?
Here it is.
Yeah, it's adiabatic. So they, as they fission and they hit together through a Z-pinch, the heat is absorbed, and the machines that actually do this using lightning are cold to the touch. So they're standing in a room that's generating so much heat that it's creating super heavy elements to form.
I struggle to speak. This makes me unreasonably angry. There's no reason why this word should make me angry so much, but I'm a mechanical engineer, damn it. And adiabatic does not mean gets cold. It in fact means the opposite of that. Adiabatic means that there was no heat transfer from no heat or mass transfer across system boundaries. So if you can put your hand to the metal and it's cold, it's not effing adiabatic. They use that word all the time, and they always use it wrong, and I am very irate about it.
Yeah, it just shows you how little they actually know, and it just illustrates their ignorance with these topics.
Yeah, the word they're looking for is endothermic. So there you go, guys. There's the actual word. Please, I'm certain that I have messed up like biology terminology, and people like Erica just like their heads explode when I say it. So I'm sure that I'm being a hypocrite, but by God, that gets under my skin.
Yeah, well, that's because you're not a biologist, so we can forgive you for making mistakes, and that's why you don't talk about biology.
Fact.
So I give you props for that. Anyway, I think that should be a wrap, and this is perfect timing because Answers in Atheism formerly known as Pseudoscience of Gravity, is having a talk with Bruce Damer and Dmitry Kunev regarding a recent paper by them on the hot spring model of abiogenesis. I am going to put that link in the sidebar chat so everyone can join Ancestors and Atheism as all of that. So everyone, make your way to Ancestors and Atheism. And Jordan, do you have any final remarks?
Just if you have any more questions or you want to hear more skepticism, you can head over to my podcast's Facebook page, facebook.com/Reason2Doubt, just so I could tell my name there. You can put something in there, suggest a topic. We're basically a skepticism podcast, so we cover everything from young Earth creationism to biblical history to aliens to flat earthers. So we try to have a good time.
Yeah, hold on. That's it, Kevin. Just caught the edit this. I do want to say that I did use your video from today. I don't want to do the work today parts because that is just fucking brilliant. So please do go through and watch the whole thing because this was a great takedown. And Vesta, so which of Nana's family acted as host for all the STDs?
It's shared equally, right?
Yep.
Yeah.
Yep. And have Jordan link the podcast. So I am going to.
That is a good idea.
Yeah. Feel free. Reason2Doubt. And here's a link to the Facebook page, Reason2Doubt. Yeah. All right. Well, I think that should be a wrap for everything. So once again, don't forget to hit like, don't forget to hit subscribe, and don't forget to hit that bell notification down below because I have a lot of content in the works. And one more thing, thank you guys again for doing this tonight. You are very welcome. It is our pleasure, and thank you, Jordan, for being on my channel and talking about this stuff with me.
Anytime.
All right. Good night, everyone. Make your way over to Ancestors and Atheism's channel right now. I will see you next time. We are out of here.